Example 13. A pin connected to bar frame is loaded and supported as shown in the figure. Determine the reactions at supports A and B. So just like example 12, we can observe that our uh, bar here has a two-force beam, which is AC, right? Or you can have it, you can also look at it in terms of BC as well. We can do that. Now, but for now, we will, but since our AC has no applied force on it, we will, it is best that we do our analysis and we will consider our AC to be the member that is or that has A2 force acting on it. Okay, so based on that, if we are to rewrite that one, our AC member, this is our A, this is our C, right? And let us say we assume that the y component at A is going up, so that's A sub y, and the x component at A is going to the right, so this is A sub x. So therefore, our C sub y component at C must be equal to the magnitude of A sub y, so that is going down C sub y, and our A sub x will have the same magnitude with our C sub x. So if this is our FA, they must have the same magnitude with our F sub C, and also it must act at the same line of action. This is our F sub C. Okay. Now the angle would be, we know that this is 300, the horizontal distance from A to C is 300 mm, and the vertical distance from A to C is 100 mm plus 100, which is 200 mm. So let us say this is our theta here. So theta is equal to the inverse tangent of 200 mm divided by 300. So our theta for our member AC is equal to 200 divided or 200 divided by 300 inverse tangent, and that is 33.69006753 degrees, and we will be needing this angle later. Okay, now we will now express this entire structure in terms of its support reactions. Okay, so we have a some sort of rectangular here, right? Okay, and A is A sub y, then we assume it to the right, right, A sub x, and then at here at point B, we have B sub y going up, right? And let us say, assuming to the left, and let's just assume to the left, B sub x, right? Okay, and then from B to there is 160 mm to the left of B, we have 400 Newton going down, 400 Newton, right? And then 100 mm above B is 600 mm. Sorry, 600 Newton going to the left. 600 Newton. Okay, so we write now the dimensions from B to our 600 Newton and to the the horizontal bar is 100, 100, 100 mm, 100 mm. Okay. And then from B to 400, we'll just have our dimensions at the bottom. Okay, here. And also we have at C here. Anyway, let's see at the very middle. Okay. And then this dimension. That is 300, 140, and 160. So this is 300. This is 140. And this is 160. All are in mm. Okay, I'll just write it here. Mm, m, m, m. Okay, there you go. So if we do force summation in either x or y, we will end up with two unknowns, right? So we'll decide whether we do moment summation at B or we do moment summation at A. Okay, still you will end up with the same answer yeah, and if we can observe, since point A and B are at the same level, so if we take moment at either any of the 2 points, one of the components will not be considered because its line of action passes through either of the points, right? So let us say I will do moment summation at A, which is this one here at the very left corner. Okay, so summation of moment A is equal to 0, assuming counterclockwise positive. So, if we observe, B sub y creates, or yeah, a counterclockwise moment about point A, 600 Newton as well, creates a counterclockwise moment, and only 400 Newton creates a clockwise moment. So this becomes now B sub y times the perpendicular distance, which is 300 plus 140 plus 160. That's 140 plus 160, that's 300 as well. So this is 600 mm. Okay. Plus 600, because 600 as well creates a counterclockwise moment, and its perpendicular distance from A is 100 mm. So this is 100 minus our 400, which is the only force that causes a clockwise moment, and its perpendicular distance is 300 plus 140, so that's 440. 440 is equal to 0. Okay, so this is B sub y times 600. I'll just drop the unit, okay, is equal to 440. Sorry. Yeah, we can have it 440 times 400 minus, right? Okay, minus 600 times 100. Okay, we divide both. Oh, wait, but before that, we solve this one first. So that is 400 times 440. That's 176,000 minus 600 times 100. That is 60,000. And then we divide both sides by 600, and we subtract 60,000 from 176. That is B sub y is equal to minus 60,000. So that's 116,000 divided by 600. So our B sub y is equal to 193.3 repeating. So let us have five decimal places again, Newton. So that is our B sub y. Since we ended up with a positive value, it means that our assumption that B sub y is going up is correct. Now, if we do summation of forces now in the y, we can actually get our A sub y, right? Because we already have our B sub y. So we do summation of forces y is equal to 0, assuming upward positive. So if you can observe based on our free body diagram, A sub y and B sub y are going up and only 400 Newton is going down. So this should give us A sub y plus B sub y minus 400 is equal to 0, and A sub y is equal to 400 minus B sub y is equal to 400 minus our value of B sub y, that is 193.3 repeating, but we use 5 decimal places. So our A sub y is equal to 400 minus 193.12345. That's 206.66667 newtons. Still positive, so meaning A sub y is indeed going up. Now, if we go back to our first illustration here that we have created, since we have concluded that AC here is a two-force member and there is no other force that is being applied at our AC member, then we can use the concept we have learned in our two-force member, and that is that if we try to isolate that member, the forces that acts at the ends must be equal in magnitude and acts opposite to each other, and their line of action is the same. And for this problem, their line of action is 33.69006753 degrees, counterclockwise measured from the positive x-axis, right? Now, so therefore, magnitude of F sub is A sub y is equal to F sub A. Now our y component, since our angle is measured from the horizontal, so therefore it is sine. F sub A sine theta. So F sub A is equal to A sub y sine theta, and we substitute our values. So this is 206.66667 divided by sine of our angle here is, let me copy this one, is 33.6900675 degrees. So our F sub A now is equal to sine of 33.69006753 sorry, it should be 260.66667 divided by answer, and that is 372.57378 Newton. So this is now the force that acts at support A. Okay, now since if we have calculated the magnitude of our F sub A, now by evaluating, we can now calculate for our B sub X if we do force summation in the X direction. So that is summation of forces X is equal to 0, assuming to the right positive. So we can observe that uh, B sub X and A sub X are to the right, while A 600 Newton is directed towards the left. So therefore, this is A sub X plus B sub X minus 600 is equal to 0. Since we are tasked to find for B sub X, because A sub X can be calculated since the magnitude of the resultant is at A is obtained already. So B sub X is equal to positive 600 minus A sub X. And we know that A sub X, B sub X is equal to 600 minus F sub A, right? Cosine theta, and we substitute now the values. That's 600 minus our F sub A is 372.5736378 cosine of 33.6900673 degrees. So let me put this in brackets because di siya maklaro nga cosine na di ay. So therefore, the B sub x is equal to, we start with cosine of 33.69006753 times 372.5736378 and 600 minus answer, and this should give us 289.245 99245, okay, Newton. So actually if we want, we can always have this as 290, but for the sake of uh to avoid some numerical discrepancies later, it is best to copy entirely what is provided in our calculator. But nevertheless, still, that is the approximation that we can get. Since we ended up with a positive value for our B sub x, then we can say that our assumption here that B sub x is directed to the right is correct. But we are not yet done since we are tasked to find for the force, right? The reaction, the magnitude of the reaction at support B. So therefore, magnitude of F sub A, or reaction, no, sorry, F sub B, the reaction at B. So that is F sub B is equal to the square root of B sub x squared plus B sub y squared. And then this is equal to the square root of 289.59 and then 15. Okay. Squared plus, and our b sub y way up here, that's 193.3 repeating. So that's 193.12345 squared. And then you write the entire square root sign. Then the magnitude of the reaction at B is equal to 289.12345 squared plus 193.12345 squared, and then take the square root, that is 348.5366173 Newton. And this is our magnitude of the reaction at F sub B. Now, we are also, although it is not specified here in the problem that we get the direction, but of course, whenever we are tasked to find for the magnitude of our force, since force is a vector quantity, so we must always provide the direction. Okay, so direction of F sub B. Since we have used already theta, let us say alpha. Okay, so alpha is equal to inverse tangent of B sub y over B sub x is equal to the inverse tangent of our B sub y is 193.3 repeating divided by 289.9999995, right? Okay, so our alpha is equal to 193.12345 divided by 289.12345, the 0.6 inverse tangent, that is 33.69006753 degrees, which is the same with what we got here. Because if you can observe again, like I said at the very start of our solution, AC is pin connected, BC is also can be considered as a two-force member, right? Okay, so that is example 13.